Hey everyone, imagine this. Thousands of years ago, before telescopes, computers, or even electricity, ancient people figured out mind-blowing facts about the universe, like how far away the sun and planets are. How did they do it? Grab your snacks, because today we're diving into the genius methods ancient civilizations used to measure the cosmos. Let's get started. First, we need to know the size of Earth to measure anything else. Enter Eratosthenes, the father of geography, who lived in ancient Greece around 240 BCE. His big idea? Use shadows. Here's how he did it. On the summer solstice, the sun shone directly overhead in Syene, modern-day Aswan, Egypt. At the same time in Alexandria, a stick cast a shadow. Eratosthenes measured the shadow's angle about 7.2 degrees and realized this angle represented 1/50th of a circle. He knew the distance between Siena and Alexandria was approximately 800 kilometers, so multiplying that by 50 gave him Earth's circumference, around 40,000 kilometers. Modern measurements show he was only off by about 1%. Pretty accurate for just sticks and geometry. Eratosthenes proved you don't need a spaceship to understand the Earth. You just need a good brain and a sunny day. Now let's talk about Aristarchus of Samos, another Greek genius. He lived about a century before Eratosthenes and was the first to calculate the distance to the moon. During a lunar eclipse, Aristarchus noticed Earth's shadow on the moon. He compared the size of Earth's shadow to the size of the moon and estimated the moon's diameter. Once he knew the moon's size, he calculated its distance by figuring out how big the moon looked in the sky compared to its real size. Using proportions, he estimated the moon to be about 60 Earth radii away. This method wasn't perfect, but it was remarkably close to the modern value of 384,000 kilometers. It's like Aristarchus was building a cosmic ruler with nothing but his eyes and some math. Aristarchus didn't stop at the moon. He also tackled the sun. He observed the moon when it was exactly half lit during the first quarter phase and measured the angle between the sun and moon. Using trigonometry, yes, the same kind we learn in school, he estimated the distance to the sun as 20 times farther than the moon. While his calculation was off, modern measurements show it's about 400 times farther. His method was revolutionary. He may not have nailed the exact number, but Aristarchus was the first to suggest the sun was much larger and farther than anyone thought. This was a huge step toward the heliocentric model. Measuring planetary distances was trickier. Ancient civilizations like the Babylonians and Greeks used a method called parallax. You've probably done this with your thumb and your eyes. Close one eye, then the other, and your thumb seems to jump positions. They recorded the positions of planets from two different places on Earth. By measuring the angles between the two observations, they used geometry to estimate distances. Imagine trying to do this without a telescope. Talk about squinting at the sky for science. Over in ancient India, Aryabhata, a legendary mathematician and astronomer, made groundbreaking contributions. In his book, Aryabhatiya, he used advanced trigonometry to explain the movements of the moon and planets. What made Aryabhata special? He accurately calculated the length of a year and the diameter of Earth. His ideas influenced Islamic and European astronomy for centuries. Host. Talk about leaving a legacy. Aryabhata was a true star of his time, pun intended. So why does all this ancient ingenuity matter today? You might think, okay, cool math tricks, but we've got satellites and telescopes now. Well, the truth is, those ancient methods weren't just clever. They were the blueprints for everything we know about the universe today. Let me show you how. First, ancient methods like Eratosthenes' calculation of Earth's size laid the foundation for modern science. His work inspired future explorers and astronomers to think globally, literally. Today we use satellites to measure Earth's shape and even track tectonic plate movements. Aristarchus's attempt to measure the sun's distance, it introduced trigonometry to astronomy. That's the same principle we now use to map the distances to nearby stars with satellites like Gaia. The Babylonians' careful sky watching, it evolved into celestial navigation, which GPS systems rely on today. Without their groundwork, you'd still be using paper maps or getting lost. Ancient curiosity fuels modern exploration. What's even more amazing is the curiosity driving it all. Ancient civilizations didn't have to measure the universe. They wanted to. They asked questions like, what's out there and how far does it go? Those same questions push us to explore today. Lunar missions like Artemis are built on centuries of understanding the moon's distance. Probes like Voyager explore planets using calculations rooted in ancient geometry. All right, let's bring it back to you. Why does any of this matter? Because those ancient astronomers show us something incredible. You don't need fancy equipment to make world-changing discoveries. You just need curiosity and a willingness to ask big questions. Think about it. They measured the universe with sticks, shadows, and geometry. What could you achieve with the tools we have today? Maybe you'll discover a new planet, crack the mystery of dark energy, or even help us travel to distant stars. The journey of discovery isn't over, it's just getting started, and you're part of it. Science isn't just for ancient geniuses or modern-day scientists, it's for everyone who dares to ask, what's out there? So, whether you're an aspiring astronomer, a curious student, or just someone who loves looking up at the night sky, remember, the universe is vast, and there's still so much to explore. Thanks for joining me on this journey through ancient science and modern wonder. If you loved this video, make sure to like, subscribe, and share your favorite moment in the comments. Until next time, keep looking up and keep exploring.